What's going on, everyone? My name is Johnny Bandon, and I will be your CCNA instructor for this CCNA video series. And in this video, we're going to go over DHCP Relay. So as you see on the screen here, I do have a DHCP server set up on a different network than any of the users in our local area network. So we need to configure R1 as a DHCP relay here. And before we dive into getting into the instructions, where I do my usual spiel about our GitLab and how you can find these labs in our Google Drive, let's just go over what we got here, right? What are we looking at? Essentially, we have two VLANs with these two subnets. These users all need to get an IP address via DHCP. However, our DHCP server, let's just say, sits somewhere out there on the internet, not local, not geographically located near us. On a separate network is a better way to describe it. Because it could be on a separate network on like a server VLAN. You got to do the same steps we're about to do here. So what we need to do to make sure that these DHCP discover messages, which are what? Broadcast, make it all the way to this DHCP server so we can finish the entire DOA process and get IP addressing information. So now how do we do that? We do that by configuring this device right here, our default gateway, or more specifically, the actual default gateway interface, with what we call an IP helper address. So we're going to go ahead and do that right now. So again, the first steps in our lab, and let me bring up our GitLab here, is going to be turn on all devices and then paste the baseline from GitLab. So now I'm going to move this off over to the right. And for our paid viewers, these labs are available to you on the Google Drive, where you can just download them and upload them to your own EVE-NG instance, and everything's going to be pre-configured. So the VLANs, the trunks, the sub-interfaces, the baseline configs, the DHCP server is already going to be pre-configured. So the only thing we have to worry about is actually configuring the relay, and not everything else that goes along with creating this kind of network environment. For our free users, we have EVE-NG videos on how to set up a network like this. And then of course, our GitLab is going to have the solutions to the lab and also a baseline for you. So step 3 now is verify all VLANs, trunks, and IP addressing. So now let's just go ahead and console in to all of our network devices. And I'm going to console into that DHCP server over there as well. And then let's just go ahead and move my face out of the screen. And in this DHCP server, what we're going to check here is make sure the pools are created. Because essentially this DHCP server is just a iOS router that I configured, right? Awesome. So in R1, let's verify our IP addressing. So let's log in with Cisco. I'm going to type in show IP interface brief. Those IP addressing is good. And again, I know this because I'm actually looking to my other monitor that you can't see with the network diagram from our GitLab page. And then we're going to go into switch 1, do some similar checks, check our trunks. We are good. And we're going to make sure we have the VLANs created, and we do. And then again, we're going to do this on all of our switches. Show interface trunk. Trunks are created. Then we're going to do show VLAN brief to make sure the VLANs are assigned to the correct ports, and they are. And then we're going to also do this on switch 3. Show interface trunk, then show VLAN brief. And look at that. We are good to go. So now let's check this DHCP server. So all I did here was I made some DHCP pools for both the subnets that this server is going to, oh, let's see here. Maybe I forgot to save, and that's okay if I did. So it looks like I forgot to save. So let's go ahead and do this configuration. Maybe this might help some of you that need some extra practice configuring a DHCP server on iOS. So we're going to make our two pools here. And this is on the actual DHCP server, not R1. We're going to do a network command, of course, /24. A default router command as a default gateway that you're going to assign to the users, a lease, and then a DNS server. Awesome. And then we're going to do the same thing for our marketing network 192.168.20.0/24. default router 192.168.20.1, lease of 7, then DNS server 8.8.8. Then the last thing I'm going to do here is make sure that this, since this is technically a router, we have to make sure that we know our route back, right? So we got to make sure that we know how to reach these networks from here. Because right now this router only knows how to talk to this. So if we have an IP helper address command configured on the sub interface, it's not going to know how to respond if that source IP address is 192.168.10.1, because if we look at this global routing table, it only knows about the 10 network. So we're just going to do a simple static route, and you could do a default here as well. But we're just going to make static routes to the actual networks that we're going to be providing DHCP services to. All right. And now let's go ahead and look at our routing table. Do show IP route. And now we know how to get there. We just made some static routes. Too easy. And before we start, let's make sure we can ping our other side, which is R1. And yes, we can. Okay. So now let's get into what we're here for. So right now, if we go on this PC and we type in IP DHCP, we're not going to get anything. Why is that? Because essentially what's happening is, let me go through this with you. What's happening is that this PC is going to send that discover message. It's going to be broadcast. Once it reaches the default gateway, that iOS device doesn't have any DHCP services running to respond to that DHCP packet where it's doing that discover. So what we got to do here is configure the IP helper address so that when the default gateway receives that DHCP discover command, it's going to redirect it over the DHCP server via unicast. So let's go ahead and do that. So one thing I'm going to do here is look at the Wireshark captures coming into the router with that DHCP and then leaving the router, which essentially is going to show us the two-way communication, right? Between server and client. And the important thing I want to note here is the IP packet, the IP header. Is it going to change the source IP to the 192.168.10.1? And we'll go discover that. So for now, let me just make sure that my captures are running, both of them. Okay. Let's make sure that we got that 0-1 capture going. All right. Now let's go ahead and configure our actual relay. So we do this on the default gateway. And since we have a couple sub interfaces, interface eth.10, the command is going to be IP helper address, and then this is going to be the IP address of the server, which is 10.10.10.1. And then we're going to do this for our other networks, and it's the same command. So we need an IP helper address under each sub interface. Or if there's a multi-layer switch, we would need that IP helper address on every SVI that we have that is a default gateway for our users. And now let's come back to PC7, and if everything's working correctly, we should be able to complete that DORA process. And look, great success, right? Awesome. So now we got an IP address from the server. If we type in do show IP DHCP bindings, look, we got a conflict there. There's a good point. Probably because we should do a DHCP excluded address on the actual default gateway. Because think about it, that 192.168.10.1, which is going to be the source IP when we send that DHCP discover this way. So in that IP header, the source IP is 192.168.10.1. Well, this believes that it should have that available in the pool. So once it receives a packet from an IP address that should be allowed to be assigned in its pool, it's like, whoa, we have a DHCP conflict. That's exactly what it said. It was like, no, we pinged this guy, but we didn't assign him. So we got conflicts here. And now if we do that again, this conflict should not come up. And we can clear any DHCP conflicts with this command here. Clear IP DHCP conflicts star. And then if we, just to recreate this, let's go down to this switch here, or this user here, and do the same thing. And let's take a look at our server. And we don't have that conflict message. And now if we look at our DHCP bindings, show IP DHCP bindings, now we should have 2. So we see the DHCP service is working, our relay is working. Awesome. So now let's go take a look at that Wireshark command, those Wireshark captures. All right. So this is, let me get my face out of the way here. So I'm just going to pause it. So I believe this is the capture between the router and the DHCP server. And I say that because we look at this first DHCP discover message. And its IP packet, like I was saying, or IP header, is going to be a source address. Where if we had a DHCP server local on the LAN, you guys know that the IP header actually is all zeros and the destination's all 255s. So a little bit different when we do this relay, right? So we have that discover message here. And it's just a typical discover message. Nothing's changed in that way, except how it's getting forwarded. And then as you can see here, this ping, something else, but so we have the discovers, then our offer, the communication is still going to our DHCP relay. The DHCP server never actually talks to the device itself that's doing the request, the actual PC. So we see that offer here coming from the server. I can just, instead of opening it up, and I guess just another regular DHCP offer message, but it's all unicast communication between the relay and the server. And as you can see, nothing's going to change as we keep going down. So some of my students ask that, does the DHCP server talk to the client directly? And as we can see from the Wireshark capture, no, it doesn't. That DHCP server is only talking to that, essentially what that IP helper, the default gateway. Then it looks like that relay is going to be essentially the middleman between that communication. So when R1 receives that DHCP offer and acknowledgement, it's probably going to send that back down to this PC. Now, if we go look at our other Wireshark capture, was this it? One second. I don't know if we actually got the correct capture. Let's do this one more time. Let me clear this off. Make sure we're getting 0, capture. And let's look at what it looks like on the other side, not between the router and the relay. And as you see here, it's a regular door process with all the broadcast messages that we should see. So here we have our discover. And look, it's within the 802.1q tag that's doing the encapsulation. We see the Ethernet frame now has that broadcast as a destination. We see our IP header with the source and destination that we saw in the last video if you watched. And then we see for the unicast transmission, which would typically be between client and DHCP server, when we configure DHCP relay, we see that unicast communication between default gateway and client instead of DHCP server straight to client. So there's a little differences we see there. But as far as the DHCP packet goes, the DHCP information, the application DHCP, it looks like everything is the same. Awesome. So that's going to be it for our DHCP Relay Lab. If you have any questions, please feel free to reach out. And I just want to thank you all for viewing and stay tuned for our next videos where we continue down our IP services section. Thank you.